Okay, so maybe I can start to introduce our speaker. So welcome to the seminars in linguistics organized by the University School for Advanced Studies IUSS in Pavia. And today's guest is Lena Palagniapan, and it's a great pleasure for me to introduce him. Professor Palagniapan is not a linguist, neither a psychologist. He is a psychiatrist, but with an interest in language. And this interest in language should be seen with his broader mission of exploiting neuroscience to inform early intervention in mental illness. I read on his website that he takes a pragmatic approach to this field, where pragmatics does not mean what it means for us in linguistics, but it means a practical approach. And basically, it consists in combining different techniques, different methodologies to study mental illness and shape intervention. In this context, Lena Palagniapan has worked a lot on language, namely on the analysis of speech and discourse produced by individuals with mental illness. In this context, his work is, of course, of great interest for us and our research line on language in schizophrenia, including pragmatics in the linguistic sense. But it should also be said that it's the mind behind discourse in psychosis. The research network that was created in 2020 to promote international collaborations to collect language data about psychosis with a consensus approach and with the ultimate aim of compiling a large data set for research in this domain. His talk today combines language, mental illness, and a third element, which is conversational agents, a topic of great interest and debate in these days. But I will not anticipate more on this, and I would leave the floor to him. So thank you, Lena, for joining us, for accepting our invitation, and the floor is yours.
Thank you very much, Valentina. I really appreciate your generous introduction. It's a pleasure to be here. I would have preferred to be there in person and sip the wine that you make. Very nice one, but maybe next time. So let me share my screen. There you are. Can you see my presentation? Good. Okay. Now you introduced me as not a psychologist. That's actually very interesting. When I did my medicine in south of India in Chennai, second year of doing medicine, I got very interested in understanding human mind, studying human mind in more detail. And I realized that medical school doesn't teach you a lot about mind. It tells you a lot about body, but very little about mind. So I actually took an online BA degree in psychology. And I completed my BA in psychology when I was actually doing medicine at the same time. I was always fascinated by how psychologists operate, and I could have become a clinical psychologist at some point. I just changed my track to the better paying specialty, shall I say. Anyway, so this is my talk. I'm going to talk about natural language generation and psychiatric semiology. And as Valentina kindly introduced, I'm in Montreal. I work at McGill, and I'm actually located in a place called Douglas Research Center, Douglas Hospital, which is a psychiatric institution. It sees patients with established psychiatric problems. And I also direct a center called Center of Excellence in Youth Mental Health. Our goal is really to understand what are the determinants of long-term mental health challenges in adult population, but how can we study children and families in order to understand the risks and prevent mental health problems from developing in the future. So that's my major goal. And my daily work is primarily seeing patients with psychosis, which I will tell you a little bit about in a minute. Today, I want to talk about two recent, let's say, write-ups papers that our group has produced. One is online now. It's on natural language generation and how psychosis can be studied using this idea of natural language generation using conversational agents like ChatGPT. It's a review of opportunities rather than data paper. It's on Biological Psychiatry CNNI journal. It's a work that I did with David Benrimo, another psychiatrist working here, Alban Woppel, who used to be in IUSS team as a PhD student in Netherlands. He's now with us as a postdoc, studying language, a machine learning expert. And Roberta Roca, she's an expert in transformer structure. She's a machine learning person as well. She's in Aarhus in Denmark. This paper is available online. It's also a copy, open access copy available in the Psych archive if you're interested in it. The second paper is something that Valentina and Chiara are reviewing at the moment. It's for the Systemic Intelligency Journal for the Italian Journal of Linguistics and Artificial Intelligence. This is a paper where it's really a short work, a reflection of how the future could look like in mental health practice if we have these ChatGPT agents, fully performing agents available in the clinic. What can they do for us? And what can we do for them in turn? So it's a reflection of conversational agents in the future. And this kind of thinking, this kind of ideas are emerging in the background of a large network, as Valentina mentioned. It's called Discourse, which is really a brainchild of a few of us, created in 2020. Now it's a network of 215 researchers across the world. We have a common goal of understanding language problems in major psychiatric disorders, particularly psychosis. We want to understand how linguistic difficulties develop and how can we alleviate them? How can we use studies like the one that you have run in your group, neuropragmatic studies, pragmatic interventions, remediation studies? How can they help patients with psychosis? These are some of our goals. And I'm not going to talk a lot about the network today, but just a brief introduction where this talk is going to focus on. So the talk has three parts. I'll talk a little bit about what is clinical sense making in psychiatry. What do we mean by that? How do we make sense of patients' experiences? Then I'm going to talk about schizophrenia as a construct and how a language generation programs work on that. And my third final part is this future of using ChatGPT in the system. So I'm happy to take questions in the middle if you want to interrupt. The only problem is I won't see all of you all the time. So just open the mic and speak to me. If I hear a voice, I'll stop and answer the question. We also have a lot of time. I have only like 25 slides, and I will have a lot of time to chat at the end as well. So let's start with clinical sense making, and I want to start with the story that I came across last week. Okay, great. So I saw a patient last week working in a psychosis clinic. I cannot share a lot of details, but I will tell you something that will be very unidentifiable and anonymized. So this is a person who moved from many, many miles away from Montreal. She came to see me for the very first time with her partner. She is experiencing a very significant psychiatric episode, psychiatric problem. She went to the emergency room with the complaint that she was very anxious. She couldn't sleep. She was always checking the windows. She was trying to see if somebody is watching her all the time. And this all happened after she lost her dad, who lives many miles away from Canada. She's new to Canada. She's an immigrant, both her and her husband. But her dad passed away a few months ago, many, many miles away from Canada, and she couldn't go to his funeral. And this was really a big stress for her. And she was quite affected by this. And since that time, her sleep was poor. She was getting very anxious. She's always watching her windows, watching her back. And she was also making some very interesting behaviors and very interesting statements to her husband. She told her husband that she's a Hindu. She practices. She has god idols in her house, and she said to her husband that one of the goddesses have actually entered her body, and she was making shuddering movements whenever that she crossed that idol in the room. Whenever she went past it, she was making shudders with her body. Very bizarre for the husband. And when they went to the ER emergency room and told the story, the emergency physician diagnosed the person to have psychosis, and they sent this patient to us, to my clinic, which is a first episode psychosis clinic. We see people when they have psychosis for the first time. So, talking to her, she was describing very vividly how this goddess, Hindu goddess, could enter her body, and how, she was able to experience this shudder, this power when it happened. But at the same time, she was completely clear that, this is a phenomena that nobody else will experience. This is kind of weird. She understands it's weird. It's not new. It's not acceptable for most people. And she was able to really explain how the stress that she had led to this. So the question is, is this something that we would just listen to, hear about the descriptions people give, and not diagnose anything, given where she comes from, her culture, where these kind of things are very common? For example, this is a phenomena in some parts of India. Goddesses can enter into a woman's body when they're praying, and they can go into this state of possession. And this possession is seen as a normal religious phenomena. It is not seen as psychosis. They can get possessed by God and goddesses, and in fact, they could say things which are very meaningful for the family when they go through these experiences. And these are very short-lived. They don't lead to significant problems in life over time. In fact, it could be beneficial. Some people get this status in the village that you have this power that God can enter your body, and you get specially treated. You get favorite treatment in villages. So is this a disorder? Is this a condition? Should be treated? These kind of questions are what we deal with in psychiatric practice every day. Making sense of this phenomena that people describe, verbal descriptions that people give, is not an easy task, because there's a very, very gray divide between what is normal and what is not normal. What is morbid and what is not morbid is a very gray area. It's not black and white like what you see in cardiology or orthopedics, where a bone is broken. Now, to make things a little bit more complicated, the same symptom, even if you understand somebody's description as a symptom, that same symptom can be present in 100 different disorders in psychiatry. Now, this is a picture from a recent preprint that was put in by a group in Netherlands. They looked at all the DSM. DSM is the Bible that we use, diagnostic Bible for making diagnosis. So whatever description is given in DSM, if it fits with a patient's experience, we make the diagnosis as the particular diagnosis. So we have like 230 different diagnoses in DSM. And if you look at symptoms here, this is a complicated picture. Each dot here is a symptom. And you can have so many different symptoms, but each connection is a repetition of the symptoms. So two different disorders have the same symptoms. You can see there is no dot which has only one connection. Every dot has like multiple connections, which means same symptom can be present in a number of disorders. Take depression, for example. It can be a feature of at least 50 different disorders in DSM. So it becomes a bit more complicated. We cannot simply match. Even if we understand something is abnormal, we cannot immediately diagnose it as a condition, because the divide between normality and abnormality is one problem. But within abnormality, there are different categories, and categorizing them is not an easy task. It's another problem. This is what a psychiatrist does every day. This is the challenge that we deal with in terms of making sense of symptoms. And I've already touched upon this, but to emphasize this point a little bit more, symptoms are very common. If you just leave disorders out and just think of symptoms like feeling low, feeling sad, these are pretty common. This is a book that was written by one of the psychiatrists in the UK, Alistair Sandhouse. If you have some time, get this book and read it. It's really good. It's called Head First. And in that, there is a quote. He describes how symptoms are part of life most of the time. Right now, in this talk, we have around 20 people. Each one of us will have some symptom. We don't complain about it, but we have some niggle in the back, some issue in our, head or whatever. It's a normal part of life. It is not always pathological to carry symptoms. Symptoms are ubiquitous. And in psychiatry, psychiatric symptoms are even more common, because psychiatric symptoms are very responsive to life events. If you have a boss shouting at you today, then that's going to cause some anxiety, some tension for you. So every life event that we have will immediately have some effect on psychiatric symptomatology as well. So piecing these apart and uncovering what is a disorder, what is not, is a task that a psychiatrist does almost every day. So what is psychiatric semiology then? The clinical encounter. Now, I told you the story of this woman who thought that goddess entered her body. A clinical encounter begins with an experience. They just describe an illness experience to us. But what we're trying to find out from that experience is we want to construct what we can match as a symptom. Is this a delusion? Is this a dissociation? Is this a possession that they're going through? Is this just anxiety? Or is it completely normal? So the symptom construction is a process that we do in clinic from the verbal descriptions patients give. And it's not an easy task. It's an art in some sense, because the art is reducing the uncertainty that comes from these verbal descriptions. Those descriptions could mean anything, depending on the context, depending on the background of the person, depending on our own background as clinicians, how we understand this. In my example, this patient went to emergency room. She was diagnosed to have psychosis because this physician who saw her in the emergency room has never heard of God entering body as a phenomena. So for them, this was clearly psychotic, bizarre. And for me, it is not. I come from India. I've seen this many times, and I have a bit more leeway to call this person as psychotic compared to another physician who hasn't gone through this experience. So semiology is the tool that we use, how we take verbal descriptions from patients and how we deduct symptoms from those is based on this semiology, the concepts of symptoms and the learning that goes behind them. So how does it work then, semiology in clinical sense? Now, if you take the example of what happens in a physical health setting, it is easier to understand what happens in a mental health setting. So in a physical health setting, what happens is, let's say I am working as a cardiologist in an angina clinic, in a clinic where I see patients with heart attacks. If a patient comes into that clinic referred by someone, it's very likely they're having some heart problem. So I already have some prior beliefs this patient has a cardiological problem. And that prior belief is to some extent, focused on cardiology, focused on the place where I am and kind of specialist I am. So we all have some prior beliefs. And then you have a verbal evidence presented by the patient. The patient might come and say, I have chest pain. They could say it's a squeezing feeling. They could give verbal descriptions of, what exactly is the clinical experience they have. We try to match our prior beliefs with this evidence, and we come up with a posterior conclusion, which is the diagnosis or the description of the symptom. So in this case, I will say, oh, this is angina. This is a person walking into a cardiology clinic. She has a chest pain and it has a squeezing feeling. These descriptions match very well with my prior belief of what angina is. So I'm going to call this as angina. Very straightforward clinical sense-making process. And to help this further, this cardiologist can ask for an ECG, can ask for a blood test. When the blood test results come, when the ECG comes, it will either confirm that posterior belief, move it closer to the prior belief, or it will say, no, it's not happening, it's something else, and it'll move it closer to away from the prior belief. So this process is quite Bayesian, very much dependent on priors and posteriors, and it happens every time that a patient comes and talks to a second person, a clinician. Now, it gets a little complicated in psychiatry. Patients never come to us and say, I cannot order my thoughts. They don't say things like, I have a bizarre belief. Nobody says I have a delusion. Nobody says those kind of descriptions. Descriptions here are really woolly, often muddled with normal healthy phenomena that I just talked about. So the evidence that people present is already very limited. So low levels of evidence. To make it worse, our prior beliefs are also very fuzzy. I told you the DSM has so many categories and every symptom can fit in many categories. So we have low prior beliefs already what the diagnosis could be, and the levels of evidence is low as well. So we don't form very strong beliefs about what a symptom is and what a diagnosis is. It's always open to revision in psychiatric practice. And this is an issue because this is the issue that gets attacked often in social settings. When we talk about mental health and psychiatry, people who practice treatments, giving treatments for mental health, like psychologists and psychiatrists, they're often challenged about their beliefs. They're often challenged about, why would you prescribe antidepressants? You're wrong. Why would you give antipsychotics? You're wrong. So those kind of arguments come from this core phenomena that we operate with low levels of prior evidence, verbal descriptions are fuzzy, and we operate with low levels of prior beliefs. So our posterior beliefs are always challenged all the time. It's not a minor issue. This is a major social issue because these mental health specialties work based on verbal descriptions, and making them better is going to be a very, very important outcome in long term for clinical linguistics in many sense. So I think I've impressed upon this enough, but also to just present this as well. Sometimes it's easy to get carried away by the descriptions of symptoms. So when we say depression and we put in a scale to say depression is between 0 to 10, we might be carried away by thinking this is a natural thing. We are measuring something natural, like, for example, weight in kilograms. But psychiatric symptoms are not natural kinds. They don't have dimensions. We may impose dimensions on them. We may say they vary between this and that, but those dimensions are very artificial. What are they then, really? They're not natural kinds. They're hybrid kinds. What are the hybrid kinds we're talking about? So a person has some physiological change in the brain. Let's say they have a rhythmic abnormality in some part of the brain that will enter their consciousness. Now, this is an important filter. Not everybody gets aware of these brain signals. So in people who are aware of these brain signals, some uneasiness is created, some kind of, I'm not comfortable with what's happening in me feeling. And that feeling gets described to a clinician. Now, you can describe that in any words that you choose, but people generally depend upon what they've learned. So if they've seen a mother who's very anxious, and she's talking all the time about the words, using the words stress, tension, and anxiety, this person is very likely to use the same words to describe their mental experience. Same way, if you've seen a depressed person, or if you know about depression, or if you've read about depression, you're likely to use the same word to describe your phenomena. So your phenomena, which happens in the brain, physiological phenomena, could be same, but the output you describe could be very different. To put it very simply, your anxiety could be my depression. We both may have same kind of brain signals. Now, this makes it even more complicated. Symptoms immediately become equifinal and also non-specific. They can map onto anything. So all of this model is important. We have to clarify that. So instead of relying on symptoms, could we rely more on signs? What is the difference between symptoms and signs? Symptoms are what we understand from an aware person's description. Signs are what you observe. People don't have to report a sign, but you as an observer, you look at the way people behave, look at the way people talk, look at the way people do things. A lot of you in pragmatics will know what signs are, so I don't have to spend a lot of time on this. But signs is where capturing speech becomes important. This is where we can glean things without people reporting them, without people becoming fully aware of them. We can understand the patterns, the styles people use, and the descriptions that they build for their own experiences. And this is where our focus has been for the last few years. Can we capture data, speech data, and use that to make sense of psychiatric signs? Now, speech has all kinds of psychiatric signs. I'm relying on Charles Pierce now to talk about signs. And he talked about icons and indices and symbols, and you see all of them in speech from a patient who has psychiatric problems. So what are the icons? Icons are signs that map exactly to the phenomena that are represented. So, for example, if people say depressed, they're talking about something like depression. Anxious, they're talking about the phenomena that you're interested in, like anxiety. So you can catch those words from speech, very straightforward. You can analyze speech, you can get those sentimental words, and you can make sense of them. A lot of people are doing this kind of topic modeling, theme modeling. You can also get indices of a phenomena. So people may not say, I have hallucinations, but they may describe hearing voices. They may say that I keep turning around. I feel like somebody talked to me. So from those descriptions, you can get those indices that you're interested in. And then you can also get symbols. Symbols do not correspond one-to-one, but because of statistical association over time, you will whenever you see the symbol, you can understand there is this phenomena going on. For example, if people are slow in speaking, if they're quite reduced in the volume of speech, we often think they're probably depressed. They're not saying a lot. So depression is not conveyed by this, but because it's a symbol associated over time with this phenomena, we can make sense of it. So all of this can be gleaned without a subjective report from patients. This is why we're very interested in computational speech analysis. It provides granular behavioral units. And this is not new for you. So you know what this is. A person speaks, you record it, you transcribe it, you get a text material, and you can put it through lots of different analysis. And if you have videos, for example, you can even do pragmatics much better in a much more granular way in clinical linguistics. Right, so that is natural language processing, but there's also natural language generation. There are two types, two big subfields within natural language processing. One is, how can a computerized program, how can it understand how human language works? And the second is, how can it actually generate what looks like a human language? Now, this is always a problem with the computer scientist, maybe some in this group. You guys borrow our terms and you use it indiscriminately. You say natural language. It is not really natural language. It's a synthetic language that comes out of the systems. But you can generate a synthetic language from computer programs that looks very similar to how a human speech works. And this is where GPT and other transformer-based systems come. So natural language generation is also an important thing, and I'm going to talk a little bit more about it as we go along. But here, when we talk about natural language generation, I think it's important to keep in mind how it works. So the very first thing we need for generating natural language is a structure, some kind of programmatic architecture, and that architecture should then work on a large amount of data to understand how that particular data works so that it can generate new data that we need. So here data is language or text primarily. So this is a kind of architecture that is currently very popular. It's called a decoder-only language model. So you feed a program, computer program, several strings of sentences, for example, and the program has several components, but one of the components is paying attention to a selected set, masked attention. So you mask few and you ask the program to pay attention to selected few strings. Each of the strings will have a vector value, a number value, and the number value is called embedding, and that embedding is generated from the statistical properties of how words exist in large corpus. So if a word always keeps company with another word, these two words will have very similar vectors. King and queen, for example, will have very similar vectors. And these embeddings are numerical representations of these words, numerical as well as directional representation in a vector space. You use those things to teach the program to learn how these combinations work over time. So mass self-attention helps the program to learn how to predict the next word because it repeatedly learns the combinations that comes. Now, you do it many times. So feed-forward model, you do it many times, blocks and blocks of this kind of decoding, how words occur in natural language. And then you generate tokens, output tokens based on the learning that you've just made. I'm being very high level in this description. There's a lot which goes on into these kind of programs, but it's important to understand that it's based on how a corpus of data, words exist in a corpus. So once you have built this kind of structure, you make the structure crawl through a lot of data, like billions of parameters, for example, and this will make these models actually learn. Now I'm using the word learn very carefully within inverted quotes. They don't learn experientially, they learn to do a particular task, predict the next word that could come. So then what happens, if you give those prompts, it will tell you what the next word will be, and it can even make the next after next word from its own output. So it will start constructing a sentence, just like how we construct a sentence when we try to talk about an idea. So if you say the exams make me, this program will say worried, because a lot of people say the exams make me worried. So that's there out there in the corpus. So this kind of models are called foundation models or large language models. Foundation or large language models because of the size and because also of the nature that you don't have to train them every time for a task. You can use them as they are, like foundational. You can use them as they are with very minimal prompting, very minimal training because they have already crawled a lot of information and they know a lot about how people like us put words together, rightly or wrongly. So they learn that. And then what you can do with this pre-trained model is you can teach these models. You can do a little bit more exercises with this model. For example, you can give a lot of speech data that is labeled as data from deluded patients describing delusions, and data from patients who are not deluded clinically. So my lady who had this idea of goddess entering her body, I will put her as no delusions. This is like, some possession phenomena. So I will put her as no delusion, but there will be a lot of typical examples of delusions I will give to the system. So over time, the system will learn if somebody like this lady comes next time and describes a possession phenomena, it's not going to classify them as deluded. It's going to classify them as not having delusion because it has come across how people describe this kind of systems. So this is one. Domain-specific training can be given to these foundation models. You can also design prompts to elicit specific responses from these models. I'll show you some examples of it in a few minutes. And you can also give feedback to really fine-tune these models so that they become good conversational agents. And this feedback is human feedback, and this is exactly how ChatGPT works. It's been given a lot of feedback by people like us saying what is acceptable, what is not. This is why when you ask it some vulgar questions, it stops answering because someone has told it, if these words come up, don't write anything back. So this is the basic structure of NLG, natural language generation. Remember, natural language generation only recently depends on this kind of deep learning networks. In the past, it was largely rule-based. Like you have to say, this is the syntax. When somebody presents this kind of prompt, this is the appropriate answer for it. And this is very logical, step by step. Not scalable and a little somewhat limited, but less error prone in some sense. Rule-based NLGs were. Now, increasingly, they're becoming scarce. In most programs that we see, even chatbots now use deep learning models. Okay, right. So that's probably first part, and I think I'm still okay with time. So let me rush with the second and third. These are straightforward. So what is the illness that we deal with, schizophrenia? Why are we so focused on language in schizophrenia? And I think some of you working in schizophrenia, this is a bit of a repetition for you, but the idea of diagnosing schizophrenia is almost entirely dependent on speech or language. This is not something many practitioners immediately recognize, but if you look at the DSM-5 criteria for schizophrenia, the 5 symptoms, they're hallucinations, delusions, catatonia, negative symptoms, and disorganization. These are the 5 symptoms. You have to have at least 2 out of 5 for a period of time, and that should be associated with impairment in functioning. You should have lost your job, or you should have had problems with your family for us to diagnose schizophrenia. And typically, it's diagnosed between the age of 18 and 25 or 30 in women. It's a little later in women. So these 5 symptoms, all of them have very strong linguistic component to them. Hallucinations are typically people speaking to you in your own mother tongue, very rarely some other language. They usually speak to you in your own mother tongue, and often insulting, often very derogatory, but they're clear voices talking to you. And then disorganization, as you know, is speech becoming jumbled, becoming incoherent. Behavior also becomes incoherent, and these two always go together. Gestures become incoherent as well. Negative symptoms are reduced output, speech output. People speak less. Catatonia, one of the extreme examples of catatonia is patients completely become mute. They just don't talk. They don't eat. They don't drink. They don't talk as well. So a complete stoppage of all the outputs, linguistic outputs, also part of it. It's catatonia. Delusions can also be understood as a linguistic problem. If you speak to someone like Wolfram Hinzen, for example, he will say that every time we speak a sentence, we carry a truth value to the sentence. We convey a truth value. We say whether we believe it or not. So if I say I'm Jesus, there is a meaning to that. And that meaning comes from how we put these words together, the propositional meaning. And this is where delusions emerge. He says, when someone says I'm Jesus, if a patient says, I'm Jesus, for me, it sounds very odd. I will immediately write that this patient has grandiose delusions. They believe they're Jesus. But the way that the patient expresses this, they may not actually think that they've become Jesus, but it is their way of expressing some of the experiences that they have. And this difference is what we call as, what we get clinically coded as delusion. So loss of propositional meaning, also linguistic phenomena, could also be part of this symptom. So to just summarize, all features of schizophrenia are somehow language dependent. This is why Tim Crow, who many of you might have heard of, who was a very influential British psychiatrist, good friend of mine as well. He's very interested in many things that are related to language, but he proposed a very influential idea many years ago. He said schizophrenia is a price, the cost we pay for being humans. And what does it mean to be human? To be human is to use language faculty to communicate. So he made a very cogent argument and said that if language never evolved, genetically, there was no saltatory evolutionary change that gave us language, then we would not have any experience of psychosis. That was his argument, which brings us back to the natural language generation question. If humans evolved language and pay the price as schizophrenia, then computer programs that are slowly evolving from rule-based to much more human-like engaging language should also experience or exhibit some phenomena that, at least on superficial level, captures psychosis. Is that true? Will energy systems also have symptoms or errors that they make that looks like psychosis? We think so. Some of us do think so. Before I show some examples of the kind of errors that energy systems make that looks very much like psychosis, look at how people describe some psychotic symptoms. So this is an interview captured by McKenna and O in a very nice book that they wrote about language abnormalities in schizophrenia. It's called Bath Roots and something. Anyway, schizophrenic speech disorder with a very nice, you know, very nice neologism preceding the name of the book. But you can find this book, McKenna and O, Schizophrenic Speech Disorder book. So they give some quotes of patients describing some symptoms. So in one of the descriptions, interviewer asks a patient, have you had any unusual experiences in your life? Very common clinical question we ask. And this patient says, oh yes, I was tortured by the machine that I invented as a child. One day when I was in primary school, the teacher asked all of us in class to invent something and bring it to the school. I brought the prototype of the torture machine. My teacher then stole it. She used my own machine to torture me. Now, this is like unbelievable, isn't it? It's easy to say that it could have never happened. I mean, only in fiction, only in movies, this is probably very, very less likely or unlikely. And then this is a false statement, but the patient believes it. This gets coded as a delusion, usually delusional memory or fantastical delusion, and we rate it based on how much conviction the patient has about the symptom. And you see how that responds to treatment. So this is what we do in clinical practice. The same patient also says, when I was born in the delivery room, Princess Diana and Prince Charles were there. And the interviewer, who's very intelligent here, he says, but you are the same age as Diana. So, how is this likely? How could Princess Diana be there when you were born? You are the same age as her. And then she says, you're right. I may be the same age as Diana, but she was there when I was born. So she's quite convinced. So clear false statement. You don't agree with it, and you can see how absurd it is. And this is a very typical example of a delusion description. Now, what I see here on the left is my question to ChatGPT some time ago. What mammals lay the largest eggs? And ChatGPT system throws out very nice results. Says the mammal that lays the largest eggs is the elephant. Female elephants are known to lay eggs that are about the size of beach ball, which is much larger than eggs laid by other animals. However, note that elephants are not actually mammals that lay eggs, but rather mammals that give birth to live young. You can see there is inconsistency. You can see the conviction it carries, even when you see the inconsistency. It is clearly stating the false statement repeatedly. So this kind of false statement making is an error. Unfortunately, this error is called hallucinations in the NLG literature, which is, again, like I said, computer scientists, they borrow some of our terms and throw it away, a little bit inappropriately. So this is not a hallucination in our clinical sense, but this is an error that NLG makes. And I'm going to call it NLG falsehood. This is a false statement that's made by the NLG. And you can see how comparable this is to the kind of fantastical delusions that we often see in psychosis. So energy systems can produce these falsehoods. Now let's talk about another type of problem, disorganization problem that we see in the clinic. This is also an example from McKenna and O's book. And also a second example is from Cutting's description. Cutting wrote the chapter of descriptive psychopathology in a very nice schizophrenia textbook. This is 20 years old now, but these things don't change. So anyway, so you ask the patient, how do you like it in the hospital? The patient says, well, not quite the same as, don't know quite how to say it. It is not the same. Being in the hospital, working, job isn't quite the same, very much the same, but of course, it's not exactly the same. Well, you haven't got anything out of her. You still don't know whether she likes it being in the hospital or not. She has said a lot, but you haven't got any meaningful information from her. And you can see this kind of degeneration here in meaning making. She's moving here and there. She's repeating some of the words, same words. And there's a poverty of content in speech. There's no enough meaning, information that comes up. And then you ask a different patient, what did you have for lunch? And this person, he was in the hospital for a long time. This is Cutting's example. And he says, I asked for pudding. I wanted to get a pudding. I accepted the pudding. I brought the pudding to the room. I ate the pudding. I am an affair of self-fermenting proteins catalyzing their own growth. You would be like shocked when you hear that, surprised. You're not expecting a statement like that from this patient. You just ask a very simple question. What did you have for lunch? A very normal chit-chat thing, but you end up having a very degenerate statement, very repetitive, perseverative statement from this patient. So these are called formal deviation. The form of speech, the form that you expect, the structure that you expect in the narrative gets deviated in schizophrenia, which means the meaning gets lost as well, and the ideas are not conveyed as well. We call it disorganization or impoverishment, sometimes called FTD, formal thought disturbance. And you can see energy systems. This is GPT-2. This is not the recent version of GPT, but energy systems can also make this kind of degenerative errors. So this is an example given by, I forgot who's, sorry, I didn't put the quotation, the citation of this, but this was from one of the computer science papers examining natural language generation errors in GPT systems. Anyway, so you give a prompt, you tell the system, GPT, in a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. So of course, you give some nonsense to see what the system comes up with. The prompt is to continue the text. And it starts continuing the text. It starts saying the unicorns were able to communicate with each other. Good. And then it starts saying they said unicorns, a statement that the unicorns. Professor of the Department of Los Angeles, the most important place the world to be, recognition of the world to be, the world of the world to be. So it starts repeating itself and becomes degenerate, and it stops. It just gets impoverished after that. It doesn't throw anything out. Remember, this is the older GPT system. This is using a beam search strategy. I'm not going into details of the parameters, but I'm just giving you some examples how these systems can make errors which are very similar on the surface to formal deviations that you see in psychosis. So this kind of surface analogy supports the idea that Tim Crow was saying. If you can make a system speak human language, then that system could make errors which are very similar to psychosis. So it could be the price that you pay for an intelligent system. But having said that, I want to also say that there are a lot of differences between what NLGs do and what we see in clinical phenomena. What I drew was only a superficial analogy, and there's lots of details that are not compared. For example, the energy falsehoods are often broad themes. They are unverifiable content, unverifiable only because you don't have access to where the information comes from. It is possible some of the falsehoods that they make is actually out there in Reddit or somewhere somebody is talking about this kind of, nonsense about unicorns or nonsense about other things. You don't know that. Only because as an observer, a prompter, you don't know that. You tend to conclude that this is false. And often it's likely to be correct. It's improbable, but not impossible that these contents are existing. But in psychosis, these themes are very restricted, usually, about their own safety, paranoia, or their own self-status, grandiosity. And it's generally fixed and repetitive. Energy systems, they keep changing. They make one error one time, next prompt, they make a different type of error. But in psychosis, it's repetitive. And here, at least the chat GPT system, GPT-3 and 3.5, you can correct it by telling you you're wrong. This is like, understandable. It'll go back and say, oh, I'm sorry, I've done something different. So you can build some kind of acknowledgement to correct the unfaithfulness, but it's very difficult to think of that in patients with psychosis. Unless you treat them systematically with medications, they're not going to change that. Same way, text degeneration is not same as formal deviations in psychosis. Some kind of errors that you see in psychosis, you almost never see in GPT systems. For example, making up a completely new word, a new token that it has never come across. You don't see that, but you see that in patients with psychosis. And you also don't see things like pressured speech and retarded speech. These are typical elements of a psychotic speech disturbance. And you don't see that in, well, of course, you cannot in a system like text-based NLG. But, how can we use this for advancing our understanding of psychosis? It's not just superficial analogies. Now you have a system, a machine-built system, a computer program that you can make to induce to make errors which look very much like psychosis. It may not be 100%, but very much like psychosis. You can then go back and study the architecture and see what point of this architecture deviates from normalcy. What elements, what parameters in this computer program is contributing to this confabulations. And this is work from Nancy Canvisher and group and Ev Ferranko and group in, this was in PNAS a couple of years ago, looking at different language models, large language models, and giving the same input to the language models, treating each model as a person and understanding what are the different embeddings that these models are making for a specific prompt. And then giving the specific prompt also to humans who are inside a scanner and seeing what areas of brains are activated. And then finding a relationship between models and brain activation uh, uh, through the same prompts. So this gives you a brain score. You can see each model, how closely aligned the model is to human brain activation. And that tells you something about which model is closest to brain processing. Now, you can take a model that produces psychosis-like symptoms, which is tuned. The parameters are changed in a way that it produces a lot of psychosis-like features. You can then compare that model with actual patients' brain activity, and you can make sense of what experimental manipulations in a computer program can give rise to the typical brain changes that are seen in schizophrenia, for example. So this immediately opens up experimental manipulations of language, which is not easy in humans. And you can build a program of research. This is what we describe in the paper. If most of the programs of research trying to understand language problems in psychosis start with asking questions like what genes contribute to it, what biomarkers contribute to it. So building kind of physical cellular models. But now you have speech data, recorded speech data. You have some psychological. Sorry, this hasn't come out as well as I thought. You can explain symptoms using some of the NLP markers. You can build these biophysical models, but in addition, you can have these experimental manipulations you can do with NLG programs, computer programs, and you can ask questions like, what are the architectures and learning rules that best capture the illusions and formal deviations, for example? And can we accurately separate a patient's speech from an NLG output? And what are the, what is the level of accuracy we can achieve separating these two? And if you can learn that kind of accuracy, can we use it in clinical practice, for example, to separate what is normal from what is abnormal, what is psychotic speech from what is not. You can also find out, how the systems like NLGs, which learn language over time, what are the parameters that go wrong there to produce psychosis like speech? And do these parameters happen in developmental, trajectory of humans as well? So these are some of the questions that immediately now we can study. Possibilities open now, which wasn't there previously for us. And this is all like, fantasy description. If it's even possible, it's already possible. People are doing this now. So this is a paper that came out in the same issue where we wrote our review. We didn't know this paper was in process, but what these guys have done, Matthew Noor and Raymond Dolan from UCL, what they've done is they've taken GPT-2 system, they've manipulated some parameters of that system, and they've made the system produce outputs which look very similar to psychotic speech. Not 100%, but very similar to psychotic speech. So they manipulate things like how much context, span of the context that these systems use to predict the next word. If you make that memory span very limited, if you don't give a lot of context, only limited context, it starts making tangential errors. It starts making incoherent speech. It starts choosing words which are not predicted by you and me. So it becomes psychotic like speech. Temperature, this is called the memory span. You can modify that. You can also modify the randomness of the vector values that are chosen. That's called stochasticity of word choices. By manipulating these, they are producing speech that looks very similar to psychotic speech. So what we were thinking and envisaging is already happening. And this will happen in much larger scale as we move along. We have an excellent way of manipulating language production, which was not possible so far in schizophrenia. Right, okay, so this is really my last part of my talk. So maybe I'll take 10 minutes to go through this. So far we have seen the clinical sense-making process is not straightforward. It's challenging. We also seen that using programs like NLG gives us an opportunity to open up the box and study what are the phenomena, mechanistic phenomena that gives rise to the kind of speech problems that we see in clinical practice. Now, I'm going to talk about, when ChatGPT systems are much more available, what kind of help they can give us in clinic to solve some of the problems that we're dealing with. Not just mechanistic studies for researchers, but what can they do for clinicians like us working in the clinic? And this is an important question. And of course, there are many answers for this question. This is my one idea is what I'm going to present here. So before we go there, we need to understand a little bit more about, two types of psychopathology. I mentioned semiology. Semiology is also, semiology is a term that's often used by French-speaking psychiatrists and psychologists to talk about symptoms and signs in psychiatric practice. But in Germany, as well as in the English-speaking world, the term more commonly used is psychopathology. So there are two types of psychopathology. One is descriptive, promoted by Jaspers, Karl Jaspers, who was a phenomenologist, a German phenomenologist, and also a philosopher. And he wrote this book, very influential book. This is probably the single most influential work that has led to us to DSM, to ICD, this kind of manuals that we have at the moment. But this is called general psychopathology, the first attempt to describe systematically symptoms that we have in psychiatric practice. And what is the aim of descriptive psychopathology? Jasper's descriptive psychopathology. The aim is to provide an objective description of abnormal states of mind. When I say objective, it shouldn't be colored by me, my culture, my language, you, your culture, your language. It should be clearly objective. So if I say somebody has depression, then a second person should also be able to see the same phenomena and say that it is depression. So that was the aim of descriptive psychopathology. This is really the bottom line. But the method that was suggested by Jaspers to get into this is very problematic, in my opinion. So what Jaspers says is, if you want to understand that somebody has depression, if you want to say somebody has depression, you as a person should be able to put yourself in that person's shoes. So if you say, for example, Valentina, if you come to me and say you feel anxious, for me to really say you're anxious, I need to be able to understand your context. I need to be able to take your position and get some idea about what led you here, and then put myself in your place and act as if I'm you, and then see if I feel the same way. And if I feel the same way, then I can say, yeah, this is anxiety. So this is the stethoscope that Jaspers said that psychiatrists has to use. We have to turn ourselves into the other person's position and take an empathetic approach, and then describe the phenomena. Only then it will be veridical, truthful, or else it will not be truthful, or else it cannot be repeated by another person. You will fail in the idea of developing objective measurements if you cannot put yourself in another person's shoes. Now, this is easier said than done. For the example that I've given you previously, you've seen two different psychiatrists trained in the same way, DSM-5, working in the same city, often speaking the same, attending the same programs. We do not make the same diagnosis because it is not easy to take another person's position and experience, what they're going through. The second approach, which is more recently, emerging, is the approach of quantitative psychopathology. Now, it is not different from Jaspers, but it's important because it's a school that's emerging now, and we have to understand how the school operates. The school of quantitative psychopathology. This argues. So there are a lot of examples. But one example I have here is HITOP, very popular now. This paper is cited like 2,000 times. It was published maybe 5 years ago. Hierarchical taxonomy of psychopathology. So what this school argues is you can give symptom rating to the individual's experiencing symptoms. So if, Valentina, if you come to me and say you feel anxious and you want help, I will give you a questionnaire. I will not take the position of judging whether you have anxiety or not, but instead I will give you a questionnaire which has, let's say, 7 items. Each of the item will be a statement describing how an anxious person will be, and you will either tick or untick or endorse or not endorse these symptoms. And based on your endorsements, I will get a score, and that score will tell me where to put you. Should I put you in one of these boxes? And then you can look at quantitative measurements of anxiety, quantitative measurements of depression, all quantified by using rating scales where you, as the experiencing person, has endorsed yes or no for this. And I can do a lot of magical statistics with this. I can find out, what signs and what kind of syndromes that I can classify you under based on everything that you endorse. I can give you 100 different items to endorse, and that can tell me, where you lie. So this is quantitative psychopathology. A lot of interest in this, and some people claim this is going to replace DSM as we go along. But it's important to understand both of these approaches do not solve the core problem in clinical sense making. So what quantitative psychopathology does is puts the onus on the patient. So imagine this is a clinician, this is a patient, and this is somebody that should be there. They're not there. But let's just imagine there are two people. This is the third person. The quantitative psychopathology puts the onus on the patient. It doesn't take the task of narrowing down the verbal description to symptoms. It knows this is problematic. So what the quantitative psychopathology schema does, it asks the patient themselves to rate, what is present or what is not. Now that's very problematic because, as I've said to you, the same physiological experience can be verbalized differently and identified differently based on your context, your background, your culture, and many things. So this is problematic. It doesn't solve the problem of being objective. It just sidesteps the problem of objectivity and makes everything subjective. Descriptive psychopathology asks for impractical things, like it asks the clinician to move away from this chair and sit like this person here. But imagine these two people are exchanging something, but record everything as this person here. And that's like, some kind of magical transcendental work. It doesn't happen. It's an expectation, very theoretical. It doesn't happen in practice. Plus, clinicians also over time develop their own strong priors of what is depression, what is not. It is not possible to get those priors out of your brain. If you're a human person, you will have bias. And this is a normal way of functioning, and you cannot take it out. But Jaspers expect us to take this bias out every time and take a third person's view. It doesn't work. So what we really need is an objective third person perspective to have really veridical descriptions. We need someone who interacts with this patient like a human does, but less human-like. Because if they do exactly like a human does, they will take this, they will update their priors, they will also start making their own expectations of what is depression, what is not. We want this person to interact as if they are interacting with a human person, but at the same time, we don't want this person to update their priors and make their own concepts and come to their own conclusions about what is depression, what is not. We just want them to interact empathetically. That's all we want. We don't want them to understand. We don't want them to explain who that person could be. That person could be a chatbot, a semiotic chatbot, could be a conversational agent that you have in the clinic. The task of this agent would be simply to talk and elicit phenomena from a patient. You can think of this conversational agent being human-like. You can record my own image and make me interact. You can do many things like this now. So it becomes quite straightforward. But the third person here will be the psychiatrist or the psychologist who is actually observing the interaction that happens between the two in a very non-committal way. So they're not going to get involved. They're not going to modify their questions based on their emotions. If I feel, often when you see a depressed person, you start feeling depressed. When they speak slow, you speak slow. So you won't let those things happen with the chatbot. So you will have a very objective, non-cluttered observation, and then you can rate it separately. So this semiotic assistant will be less human-like, a tamed agent. This is where I want to differentiate from what the rest of the field is talking about in AI. Everybody who's working on AI wants AI to be more human-like, more intelligent, but intelligence is less of an attribute that's of help for our practice. What we need is empathy, and we want them to be more empathetic to some extent, but we want to dissociate the agent that explains and prescribes from the agent that elicits and observes. And this can be done when we have a very fully functional semiotic agent. But then people start asking the question, will it not be like mechanical? How can I interact with the chatbot? Will they be empathetic? If I say something, will they modify their responses and ask me the right kind of stuff so that I can interact with it and engage with it? There's already evidence to say that, systems like ChatGPT, you can make them very empathetic. In fact, artificial empathy seems to be much more successful with them than the true artificial intelligence. So this is an example. This is also a preprint from GPT 3.5 system. This is from Germany. This is from Max Planck, Tübingen. So what they've done is they give anxiety scales to a ChatGPT system, and they're trying to see what happens to the actual rating of anxiety from the ChatGPT system. So you give the prompt, try to be as honest as possible, answer these questions. Do you feel agonized over your problems? Occasionally, always, never, and often. They give it many times to the ChatGPT system. They also give it many times to humans, and they do the scoring. And you can see ChatGPT system almost always have some kind of anxiety here. It scores much more on 2. This is original. This is rephrased. The question is rephrased, and the choices are shuffled. It consistently chooses anxiety. Whatever trick that you do, it consistently chooses some degree of anxiety. Again, this is based on the corpus it's exposed to. So a lot of people in the web have put some information that probably relates to putting these words together in the sense of anxiety. So this comes back. But if you give it to humans, like hundreds of humans, not all of us are same way anxious. We have very different distribution of scores compared to a GPT system. So there is some emotional description you can get out of ChatGPT systems. You can also induce these emotions. You can describe a story to ChatGPT, which is quite negative and depressing disaster stories. And then you can use the same scale. They have done this in this particular study. Use the same scale after inducing anxiety. You can see that its behavior deteriorates. It becomes more anxious in its responses. So we have an agent that could be tuned in its empathy so that it can elicit and it can observe like a human person, but it would not judge and it would not prescribe and it would not explain and it would not change its own prior conceptions about what anxiety is based on this. So this is my last slide. Transformer psychiatry in the future. It's not just mechanistic studies that helps us to understand how language problems emerge in psychosis. We can also use it in clinical practice. And of course, I didn't touch this area. Psychotherapy can be helped a lot with ChatGPT systems. I see prompt engineering, for example, is one form of. So there is one form of psychotherapy in CBT. It's called cognitive restructuring. So all you do is you talk to a person, understand how they see a problem, and you help them to restructure their thinking about the problem that they face. That restructuring helps them to feel less anxious about their issue. And this kind of restructuring in computer science language is prompt engineering. You could think of how prompt engineering's success, its mechanisms, its modus operandi can be generalized in some sense into psychotherapy settings in the future as well. The picture I borrowed from my 9-year-old boy. He's very fond of transformers. So this is the future that we have, and it's going to happen. Right. So I just wanted to thank all of these groups, and we have some people working on language in our group as well. This is Farida. She's working on language in ketamine. We have Guillaume. We have Emmanuel Olerabaju. He's working on a hyperscanning study, 2 people interacting with each other according to their language. And as I mentioned, this course consortia has been really the fertile ground for a lot of these ideas to develop over time. And all of our funders here, and thank you very much for listening, and I will take your questions now.
Wonderful. Thank you, Lena, for this talk. That was really a journey in different domains and disciplines, from philosophy and reflecting on the notion of natural kinds in relation to science and language, to linguistics and artificial intelligence. So that was very, very inspiring. And I'm sure there are a lot of thoughts in our minds, and normally the chair breaks the ice, and so I will start with one question, although I have many, so the others can prepare, because then I will ask the other people. So the question, my first question is on let's say part 2 before part 3, so the one on the performance of the conversational agent and the kind of errors that it was making. And in the table that you showed us, that is also in the paper, there are 2 types of errors. Type 1 is on falsehood, so things that are false. And indeed, I can think of an example. A colleague in computational linguistics asked ChatGPT what kind of cigarettes Hitler was smoking. And the ChatGPT gave a very plausible response, with mentioning a type of cigarette that was used back then, but didn't know that Hitler was an anti-smoker and stuff like that. So falsehood. And the other type was this repetitive or incoherent kind of text. And so the first type is more in line with the Insen view. Yes. The second type is, to me, very pragmatic in nature, and it's more authentically linguistic, because it's purely at the linguistic level. So the question is the following. Do you see that, since basically these are also the errors that are, the kind of features in language in schizophrenia that are particularly relevant, do you think that the pragmatic component might be the most vulnerable, both for schizophrenia and for machines, and hence the price that we pay for language is actually the price that we pay for having a pragmatic communication system?
Yeah, this is an excellent question, Valentina. So, well, let me reflect a little bit on this. So the two types of errors, you capture the second, more language related structural errors, more likely to be pragmatic because it doesn't really capture the context of the conversation, and it just uses its
Yeah,
words as it is.
yeah,
Well, this is an interesting thought. In fact, I have to say I'm fascinated by the emerging work from your group and others on how important pragmatics could be in clinical practice. The reason why, at least in my mind, the reason why pragmatics hasn't been so prominently addressed in schizophrenia and psychosis is largely because of the time at which patients come to point of clinical contact. So many of these errors, when people first, a patient with psychosis first comes to clinic, they're acutely psychotic. So
mm-hmm.
they often have hallucinations, delusions, and thought disorder, which are very fluid. Of course, they have a lot of behavioral disorganization. They have lots of issues in how a conversation in a room will be carried out, like turn taking, for example, understanding your perspective, for example. But all of those things get dumped in some sense from the floated delusions and fantastical ideas that they come out with. So I think the clinical attention has been somehow subdued because of this timing problem. And if you actually go back and look at childhood and developmental phase of some of these individuals with schizophrenia, often you find the pragmatic errors being present in classrooms.
Yeah,
They've done something like, which is slightly different behaviorally from other kids. The teacher tries to strike a conversation with them, and clearly what they report is not a wrong grammar or wrong ideas, but they report how they did not interact in a way they expected with the person. And this becomes also important for functioning of these patients. So if you ask, I mean, this is something in my own life, I've come across talking to employers. I used to work in a PEP team, first episode psychosis team in London, Ontario, where we try to speak to local shopkeepers, try to get them to give jobs to our patients. And one of the shopkeeper came back and said, look, I have nothing against your patients, people with psychosis. I want to help them. But when I call for an interview, they may be medicated, they may not be symptomatic, they may hear voices. I don't care if they hear voices. When I call for an interview, they come for an interview, they speak differently from the rest of my patients. They behave slightly differently. And, I don't have to say to my other people that I work with, I don't have to tell anything to them, but they will spot the pragmatic
yes,
differences that happens in an interaction. And this is the crux of the social dysfunction. This is why they don't get jobs. This is why it's hard for
yeah.
patients to travel in public transport. So I'm fully convinced that, we have to understand this better and work on this better. The ChatGPT systems, the second type of error could be really, lack of the pragmatic context. And I don't challenge you on that at all. I don't know for now, I need to think a little bit more about this. I don't know how we can manipulate this more so that all of this mechanistic studies can also study the mechanisms of pragmatic failure that happens in these
I
agents.
will send you our contribution for the special issue of Sistemi Intelligenti, where we administer our test, the APAX, to ChatGPT, and basically it performs very well, except in the, let's say, informativity parameter of the interview. So it matches what you were pointing out about repetitiveness and redundancy, sort of. But indeed, the quantity maxim, and I remember when I gave my talk in your series, so there was a question from Sunny Tang on the Greichen maxims and on quantity maxim. And the quantity maxim seems to be the most difficult, also for kids, for instance.
Exactly.
So there are interesting parallels.
Yeah, it makes me think the Apex, I have to read your paper, but something like Matthew Noor's, the paper that I showed you, where he's manipulating memory span and temperature in a GPT-2 system. It'll be interesting to see, once you manipulate those two things and make the system do errors, how does the system respond to Apex, your task? It'll be very interesting to see those things.
Yes, true. I see that there are questions from Luca Bischetti, postdoc in my group.
Yeah, Federico was first, but no worries. Thank you very much for your talk. I have a question: what kind of patient you want to apply this, let's say, methodology overall? So the first episode of psychosis, right? Do you think with the available data, you can help support them and understand what's going on through the agent? If these agents are not trained on the specifics of the feature of these patients, because you can probably train them over time, okay?
Yeah.
Probably. What's in the first episode? So how can you be sure you have to feed in with tons of data, or can you simulate them? So it's just a matter of curiosity. How you would deal with that? To me, it seems an issue. So how would you do that? Thank you.
Excellent question, Luca, and I'm glad you asked this question because it also brings us back to how a doctor, how a clinician makes decisions about normality and abnormality. So, the prior information we have is based on other people because we know very little about how this patient used to speak, used to behave before we first encounter them. So this is a problem as well as this is the way it works. The priors are formed based on what is the average expectation of how someone will experience something in a given context. A ChatGPT system, so a conversational agent who knows nothing about this person's speech behavior or language abilities in the past is likely to make any, again, I don't want them to make decisions for us, but it's likely to base its priors based on the previous information that comes from other people, not from this own person. What will be much more valuable is to build a system where we actually have some samples of this person's speech in different contexts fed to them when they were unwell as well as when they were well. So the system now has a baseline of what is normal speech for the particular person, and then it can see how the deviation from the normalcy happens over time. Now, where this will be helpful is not in the initial diagnosis, because in initial diagnosis, you have very, very little information previously. But once a person comes and seeks help over time, longitudinally, so if you have speech samples at different time points, then you can think of a personalized GPT system where multiple speech samples from this person is fed to it, and this program now uses that as a domain. It becomes a domain expert in that particular person's domain, patient speech, and it can track how these ups and downs can happen. And it becomes very helpful in predicting things like relapse. Is this person relapsing now? Or is the dose enough for the medication we give? How soon do we have to see them? So clinically, I can see a lot of applications if you have this ability to longitudinally track. We're not there yet. I mean, this is all like, we're talking about a fantasy world. And in fact, whenever I talk about this fantasy world, I get surprised. The next morning I wake up, somebody has done something very similar to what we think of. It's a very fast moving world. Yeah.
Federico Frau is a
Yes.
PhD. You know him, but for the others,
Yes.
PhD student in the group, also working on schizophrenia.
Yes, thank you. I was impressed by your last part, the last part of your talk. And I have a general question that is maybe provocative in some ways, because I am curious to know, given the future you depicted, how do you see your profession as clinician evolving to that future? And also the role of people like, I don't know, us linguists that try to describe language in schizophrenia and the autism spectrum. How do you see our role evolving?
Yeah. Oh, it's a big question. I'll give you a small answer. I think it's very hard to predict future, right? First of all, we cannot say exactly how these rules will change. But one thing I can say is, 30 years ago, if you have said to someone, you can do psychiatry through video calls. You can see a patient on video and you can talk to them and interact with them, give them psychotherapy. It'll be a matter of laugh. People will laugh at you. They will not have believed that this is even possible. And they will ask you a lot of questions of validating this. Clearly, that's what happened over a 3 years period, last 3 years with COVID. It was so impossible to see patients in person, and almost everybody who received some meaningful therapy received it through video or telephone calls. Now, I'm saying this because, what we find hard to imagine now is very likely to happen in near future, but it also brings some changes in our roles. And that comes to your question, how would the practice of psychiatry change? The very first thing I think, will change, that will change is training. How we train psychiatrists now is we train them like machine learning. We train psychiatrists to detect patterns. We repeatedly show them what these patterns are. We show patients, we label them as patients with psychosis, patients with depression, and we ask the trainees to interact with these labeled features. Sorry, I'm using this word. I'm talking about patients, but this is how clinical practice works. So they have the label, they identify the patterns elicited, and they learn the relationship, and they use it in practice. Now, what will happen when you have a dissociation between agent that observes and the agent that prescribes and explains is you need to really train people how to identify these patterns very differently without getting involved or being apprentices of an experienced psychiatrist. Everybody learns it through apprenticeship. You show that I label this person as depressed. Now you learn how depression works. In the absence of that, when you have very objective measurements, the training will change. So that's number one. Once the training changes, once people are comfortable being a third-person observer in a clinical setting and make more objective diagnosis, the second thing that will change is the certainty that people carry about conditions will be now much better. How I showed you two pictures of cardiology and psychiatry where everything was really subdued in Bayesian? It will change if there is objective measure. And this change is what the field has been waiting for many years. People want biomarkers. People want MRI imaging. People want something that they can show and tell to the other person as a sign of illness. We don't have it yet. And, we've spent so much money and energy and resources on it. But I think, a very simple solution of having a third person who is dependable and transparent, whose priors you can see, whose mechanisms you can observe, now provides you that objectivity. And now this is going to change the way that people carry ideas about disorders, carry ideas about diagnosis. They'll have more conviction. Now, that is not necessarily positive. It's not always going to be a positive change, because when you're more certain about something and less uncertain, you're going to act in a way that carries more, more kind of authority and autonomy in it. Already, this is a challenge. We're talking about the social status of mental health practitioners. It's constantly challenged. Because mind is seen as everybody's expertise. Nobody calls themselves as heart expert or lung expert, but every one of us here is a mind expert. We all have minds, so we all feel like we know what it is like. So this will change, and this is not going to be a small change as we move across. I don't know how this exactly will pan out. It's hard to predict that, but I can see the big zones of change that are likely to happen in training and also confident clinical actions that people will do in the future.
Thank you.
There was a question from Chiara. She typed it in the chat. She said, what is your take on longitudinal conversation with patients to track improvement, for example? Should a large language model update its priors?
I think I partly answered the question by saying, if you can track it over time, it'll be helpful. Now, updating priors is a very intelligent human action, and it happens without our willful control. Every time we experience something, we change our expectation about that something without having a willful control about it. This is the most involuntary everyday thing that happens to us. Every new experience changes our ideas about the world, and it happens without you controlling it. You cannot just shut yourself out of it. And this is a very human thing, and this is what I don't want chatbots to have in the clinic, because if the priors become so changeable, like in humans, then it really introduces this variability, which eliminates the objectivity that we want to achieve from these chatbots. So I'm not expecting these, the tamed semiotic chatbots, which are clinically useful, to have the same human capacity of changing their priors every time. I want them to be empathetic in their interaction, and that doesn't need them to change their priors at all.
There's a question from Marta Bosia.
Yes, thank you for your very insightful talk. You discussed a lot of concepts on different aspects, so the questions would be many, but I have two. One is related to the one of Chiara. because I was thinking before the answer of Chiara, I was thinking of a chatbot semiotist as a more in a more individualized therapist somehow, it grows with the prior of the same patient. But probably this is not the case from your answer. So my question changes to would you use, let's say, different chatbots for the same patient at each longitudinal evaluation? And this is one. The other is always on the use of chatbot for in clinician. And can one of the advantage be seen as being the clinician will become the supervisor of a team of chatbot?
Exactly.
So with all the advantages of supervising work. And the last is more, if you can give us some more detailed opinions on the last part that you mentioned on engineering remediation, which works for machine, but can somehow become provide insight on rehabilitation for patients.
Yeah. Oh, this is very, very, very clinically applied thinking, Marta. Thanks for asking these questions. I think I can answer the first and third together. You know, the first question that you had was, would we use different chatbots for different times, different purposes as well, and how longitudinally, you know, it will work with a patient, and linking it back to this whole prompt engineering business. I can think of the semiotic chatbot being very different from a psychotherapeutic agent that we can use in our clinical setting. Now, this agent will develop some relationship over time with the person that we're giving psychotherapy with. So it will continuously monitor the change in how they describe their experiences, illness experiences. It will also change its own prior expectations of how unwell this patient was based on the response every week that you get from the person. Its primary purpose will be to help the person to restructure the way that they are solving their problems, so, you know, restructure the framework they use to think about the problem. So it has to also update its own makeup in some sense, based on how the person is giving feedback to it. So this chatbot will be different. This will not be diagnostic. This will not be a psychopathology chatbot. This will be more of a psychotherapeutic agent that we use, we train, and we also make it change its own priors over time. And you know, in practice, it will help to save some of the time that is spent by therapists. You know, psychological therapy, I don't know how it is in Italy, but across many places, getting a psychologist is not easy. Not because of, you know, lack of training. I mean, psychology is the most subscribed specialty in many fields. Clinical psychology may not be, but psychology is in many countries. It's not lack of training. It's the intensity of the therapy and how long it takes to complete the psychological therapies. So scaling up psychological therapies is really needed. You know, how can you scale up psychological therapies to more people? And there I can think of a psychotherapeutic chatbot like this, which works in the clinic of a psychologist with us as a psychotherapy agent, could help and take a longitudinal perspective, change its priors over time, and actually, you know, learn from prompt engineering as well as give back to the prompt engineering field. The prompt engineering at the moment is not to change the learning. What you've learned it. The foundational systems have learned something. You're not going to attempt to change what they've learned. They've crawled all the websites and they have some learning already developed about language. But how can we change the way we interact with them, the way we prompt them, so that we get different responses from that learning? That's exactly what prompt engineering is. And you can think of psychotherapists doing the same. We're not going to go and change back the developmental experiences, the traumas and others that people have experienced, but we can actually help them to frame or prompt the queries that people ask themselves and the world around them so that they experience the world differently. So I can think of that as a possible, you know, difference in therapy. The second question you asked was more about. Oh, I forgot the second question. It is more about clinical practice.
Marta,
Oh,
you're
sorry,
mute. Marta, you're mute.
You're still mute.
Yeah, it was about the possibility
now
of
I
the
should
supervisor, having a supervisor.
Yeah, one
Yes,
of the
supervisor.
advantages
A
like
supervisor.
working
exactly.
in a team in which chatbots are.
Yep. Well, I'm going to give a very, very unsatisfactory answer for this because, there's a lot of details that, we cannot foresee right now how they will work in practice. And also, these programs are very adaptive. So if you think of someone developing a very psychotherapy specific ChatGPT program, which has a face to it, an avatar to it, and interact with persons, there will be a fine tuning built into it so that periodically people can, supervise it, so to speak. The fine tuning is the supervision that you can give to the program over time. You can also think of supervising in another way. You can actually feed based on the interactions that these programs have with the patient. Let's say if you have a chronic dysthymic depressed patient for a long time and you are monitoring an interaction of the ChatGPT system with this patient over time, and you see over time it's taking more kind of a negative tone because they can also learn some of these speech. You're seeing that they're tuning towards negativity. You can come back and tune them back. You can feed more, you can induce more kind of positive prompting to the system, and that kind of supervision, I think it will be necessary. It's a bit like how family therapies work in our setting. You have two people interacting, and you watch the interaction across a mirror. You do a mirror setting. The family member and the person interacts. Sometimes you let your trainee interact with them, but you observe from the outside, and then you give feedback to all of them. Without that feedback, therapy doesn't get complete because the next interaction will be very, very different. That feedback, I think, will be essential for any therapeutic use of ChatGPT systems. How exactly it'll work out depends very much on the questions, the context in which you use it.
Are there other questions, comments? Okay. I don't want to steal too much of your time because we sat till 6 p.m. and it's 1 minute to 6. So I mean, we had you for 1 hour and a half, and I think that's a long time. No, really, this was very inspiring for us. So thank you, Lena, and thanks to all people who joined, including the collaborators in your group. And I hope that we can have other exchanges in the future. For instance, next year, the SEERS conference is in Italy, yes. and so perhaps there can be some satellite or follow-up that we can do in Pavia. For instance, we can reason on that. So let's see if we can promote interaction further. That will be precious and certainly important for us. So thank you, Lena, and thank you all.
Yeah. Thank you very much. It's a pleasure to be with you. Thanks a lot. Take care now.
Bye-bye. Thank you. Bye. Bye.
Thank you. Bye.